Hello everyone. Let us move to the next lesson, that is aldehydes, ketones and carboxylic acids. In previous lesson we learned about carbon oxygen bond, right? About compounds containing carbon oxygen bond, that is carbon oxygen single bond. In this lesson, we are going to discuss compound containing carbon oxygen bond, that is carbon oxygen double bond, right? In previous class, we discussed about alcohols are OH, carbon alkyl, if take CH group, carbon oxygen single bond, and phenols aryl group and OH, right? In this aryl group and OH single bond, and one more ROR, carbon oxygen single bond. This is what we learned in previous lesson. In this lesson, we are going to discuss compounds containing carbon oxygen double bond, that is aldehydes, ketones and carboxylic acid, very important functional groups, right? See, these aldehydes, ketones and carboxylic acids containing carbon oxygen double bond, and this functional group is called carbonyl group. So in this lesson we are going to learn about carbonyl compounds, right? Carbonyl compounds, carbonyl functional group containing compounds. Let us see one by one. Let us see the examples or general or functional groups, general representation of functional groups in case of aldehydes, ketones and carboxylic acid, and you already know about this. First one is, I will take first one, R C double bond OH. Okay, that is, this compound is called aldehyde. Generally these are called aldehydes or aldehyde, right? What are aldehydes? Aldehydes are carbonyl compounds, right? Carbonyl compounds in which carbonyl group is bonded to hydrogen atom and one carbon atom. Am I clear? These are carbonyl compounds, right? These are carbonyl compounds in which carbonyl group is bonded to hydrogen and carbon, to one hydrogen and carbonyl group is bonded to, that is carbonyl carbon is bonded to one hydrogen and another carbon atom, right? This is about aldehyde. Next is ketones. What are ketones? R C double bond O R, symmetric one, or R dash. These are called ketones, right? Ketones are nothing but carbonyl compounds, carbonyl compounds in which carbonyl group is bonded to two carbon atoms, or carbonyl groups are bonded to two alkyl groups, right? This is about ketones. Next one is R C double bond O H, okay, or R C double bond O R or R dash, or R C double bond O C double bond O R or R dash. These two are, first, this is carboxylic acid, RCOOH, carboxylic acid, right? Carboxylic acid. These two are derivatives of carboxylic acids, right? If we replace this hydrogen, we will get those two compounds. These two are derivatives formed from carboxylic acids. Derivatives of carboxylic acid. First one is, this one is ester, right? Ester functional group. Second one is anhydride, right? First one is ester, second one is anhydride, right? We can write this compound as R C double bond O C double bond O R dash, one and the same. Now, what are carboxylic acids or derivatives of carboxylic acids? These are carbonyl compounds. Carboxylic acids also carbonyl compounds in which carbonyl group is attached to oxygen atom, right? Carbonyl group is attached to oxygen. Carbonyl group is attached to oxygen, right? These are carbonyl compounds. Carbonyl compounds in which what? Carbonyl group is bonded to oxygen atom. Carbonyl group is bonded to oxygen atom, and one more is a carbon, right? This is about aldehydes, ketones and carboxylic acids. Hope it is clear for you, right? In this unit we are going to discuss about these three compounds. One is aldehyde, ketones and carboxylic acid and its derivative, right? Next, what about other compounds having carbonyl functional group? Let us take two more compounds containing carbonyl functional group. First one is R C double bond O NH2. What is this compound? This compound is amide. This is amide functional group, right? Amide functional group. What are amides? Amides are nothing but carbonyl compounds in which what? Carbonyl group is attached. Carbonyl group is attached to nitrogen atom. Right? Carbonyl group is attached to nitrogen atom mainly. Next is acid halides or acid chlorides or acyl halides or acyl halides. Same, acyl halides. Yeah, I will write here acyl halide or C double bond O X, where X is halogens. X is halogen. Now what are acid halides or acyl halides? These are carbonyl compounds again, right? Carbonyl compounds. These are carbonyl compounds in which carbonyl carbon or carbonyl group is attached to halogen atom, in which carbonyl carbon or carbonyl group nil carbon is bonded to halogen atom. This is about carbonyl compounds, that is carbon oxygen double bond. First one aldehyde, ketone, carboxylic acid, amides and acyl halides. In this lesson we are going to discuss about these three compounds. Now what are the importance of aldehydes, ketones and carboxylic acid? These aldehydes, ketones and carboxylic acids plays very important role in biochemical processes. Okay, we can find these compounds basically in nature. That is, we can extract these substances or these compounds are present in naturally occurring substances. Most of the organic compounds present in nature. Right? Next, these aldehyde and ketones plays very important role in a biochemical process. Chemical processes. Okay. Now, and these compounds adds fragrance and flavor to the nature. Okay, these compounds give fragrance and flavor to the nature. Now let us see some naturally occurring aldehydes or naturally occurring these compounds. First one is vanillin. Okay, vanillin present in vanilla beans. We already know about vanilla beans and we know about its fragrance, right? Vanillin, compound name is vanillin. Structure of vanillin is one of the aldehyde. At meta position, methoxy group is present. and at a para position OH group is present. This is about vanillin present in vanilla beans. Next one is meadow sweet. Okay, or I'll write first compound. Salicyl aldehyde present in meadow sweet, one kind of herb. Meadow sweet. Okay, structure of salicyl aldehyde is, here it is CHO and here it is ortho position OH group. This is about salicyl aldehyde. Next one is, third compound is cinnamaldehyde. Cinnamaldehyde. We all know about the cinnamon, right? One kind of spice, right? Cinnamon. It is obtained from cinnamon. Okay. What is the structure of cinnamaldehyde? CH, double bond, CH and CHO. See, these three are important aldehydes which are occur in nature. These compounds adds fragrance and flavor to the nature, and these are used in food and pharmaceutical industry. Industry to add flavor or fragrance to the substances, and also these compounds show some medicinal property, right? This is about aldehydes present in nature, that is vanillin from vanilla beans, salicyl aldehyde from meadow sweet, and cinnamaldehyde from cinnamon. Now, what are the other uses of these compounds? Aldehydes, ketones and carboxylic acids. So, these aldehyde, ketones and carboxylic acid are used as solvents, mainly as solvents in chemical reactions, right? Solvents, mainly we are using acetone as solvent here. Ketone, one of the ketone, CH3, C double bond O, CH3. Acetone used as a solvent, or these compounds are used as adhesive and used in paints, okay, in paints and fabrics and resin. Next, plastic, etc. So, it is very, very important to study these compounds because it finds a large number of application in the field of science or in the field of organic chemistry, right? In this unit, we are going to discuss about nomenclature of aldehydes, ketones and carboxylic acid, preparation of aldehydes, ketones, carboxylic acid, its reactions, and again some uses. This is about this lesson. Okay. Now let us start with your favorite one, that is nomenclature. Now we'll focus on the nomenclature of aldehydes and ketones. Aldehydes and ketones. In that first one, two naming systems are there. As we know, one is IUPAC system of nomenclature. Next, one more is a common system of nomenclature. But in case of aldehydes and ketones, we usually prefer, or we in more practice we are using a common name, okay, instead of IUPAC name. For example, you are knowing we are rarely says methanol, right? Always we call methanol as a formaldehyde, right? Or ethanol, instead of that we call is an acetaldehyde, right? In most of the cases we call these aldehydes and ketones in their common names. Let us discuss nomenclature of aldehydes, okay? Nomenclature, in that first we'll see aldehydes. First one is common name. Yeah. Common name of aldehydes are derived from their respective carboxylic acids. Suppose if we have acetic acid, the common name of common name of acetic acid is acetaldehyde, which is derived from its respective, that is its acid, right? Or formic acid, its common name is in its aldehyde is formaldehyde. Common name formic acid, formaldehyde. Acetic acid, acetaldehyde, right? So common name is obtained from carboxylic acids, respective carboxylic acids by replacing ic or oic, in their cases oic or ic of carboxylic acid with by replacing ic of carboxylic acid with the aldehyde. Okay, how? Let us take one example. So these are derived from their respective carboxylic acid, as I said. I will take one example, acetic acid, right? Acetic acid, one carboxylic acid. So common name of aldehyde is derived from its carboxylic acid by replacing ic by aldehyde. So common name of this compound is acetaldehyde. Hope it is clear for you, right? Acetic acid to acetaldehyde. Or benzoic acid, oic acid, there we replaces oic by aldehyde, oic acid. Or formic acid, ic by aldehyde. This is about a common name of a carboxylic acid. And also these common names are derived from their sources, right? Their sources, that is Latin or Greek words. Again example, acetic acid, that is derived from its Latin or Greek word, that is acetum. It is derived from acetum to acetic acid to acetaldehyde, like that, from sources. Or formic acid, formic acid, formaldehyde, right, like that. Okay, present in red ant, right? Or it is vinegar. In acetum means vinegar, like that. Now next is the position of substituent is position of these are rules. Substituents are indicated by, position of substituents are indicated by Greek letters like alpha, beta, gamma, delta, etc. Okay, position of substituents, or if there is bromo group attached to carbon, are represented by alpha, beta, gamma, etc. And carbon next to the aldehyde, carbon next to the aldehyde will be alpha. After that alpha, next to the alpha carbon, then it will be beta carbon. This is about a nomenclature of aldehyde in a common system of naming. Let us take few examples for this alpha, beta, gamma and all. I will take textbook problems. First one is CH3, CHBr, CH2 and C double bond OH. Let us see this example. It is there in your textbook, right? I will explain those examples. Okay. Now, in common system of nomenclature, as I said, here functional group is aldehyde. The carbon next to the functional group is alpha carbon. After that, beta, next is gamma. Now, name of this compound is, at beta, bromo is there. Hence, name of this compound is beta bromo. At beta, bromo is there. How many carbon atoms are there? 1, 2, 3, 4. Hence, it is hence its acid is butanoic acid. Right? Sorry, butyric acid. Hence, its compound is butyraldehyde. Right? Its name is butyraldehyde. Total number of carbon atoms 1, 2, 3, 4. Hence, it is its common name is butyric acid. Ic is replaced by aldehyde. Hence, its name is butyraldehyde. It's about the common name of this compound. Next, we'll move to the common name of the ketones. Okay, common name of ketones. Ketones are named in common system of nomenclature by naming alkyl or aryl group. Okay, alkyl or aryl group attached to carbonyl compound by naming alkyl or aryl groups attached to the carbonyl group. Okay, that is R C double bond O R dash, or here if it is alkyl group, methyl. If there is two methyl groups are there, then we can name it a dimethyl ketone, right? Dimethyl ketone, or methyl or if one is alkyl group, another is aryl group, then we name this compound as acyl phenyl ketone, or we are taking acyl group as prefix to phenone. Okay, I'll explain by taking example CH3 C double bond O CH3. So dialkyl, right? Alkyl ketone. Its name of this compound is dimethyl ketone. Dimethyl ketone. Right? Now for this CH3 C double bond O CH3 C double bond O C6H5. Right?